For over 4 decades, the Voyager 1 spacecraft has been the ultimate explorer, a lonely traveler on a highway stretching into the cosmos. And just when we thought we had heard all its tales, Voyager turns its head, sending us a cosmic postcard with news that's got even the smartest brains scratching their heads. What on earth could it be? Stay tuned as we delve into Voyager 1's latest and most bewildering chapter yet, a discovery that challenges what we thought we knew about the vast universe. Chapter 1. History of the Voyager Probes. Back in the swinging 60s, an epic adventure began with the launch of two intrepid spacefarers, Voyager 1 and Voyager 2. It was a time of big dreams and even bigger ambitions. Think about it. This was a time when computers were as big as rooms, and the internet was just a twinkle in a few scientists' eyes. The task? To take advantage of a once-in-a-lifetime planetary alignment and slingshot across the solar system, visiting our giant gaseous neighbors, Jupiter, Saturn, Uranus, and Neptune. Enter Gary Flandreau, a whiz at NASA's Jet Propulsion Laboratory. With just a trusty pencil in hand, he plotted a trajectory that seemed like something out of a sci-fi novel. You see, every 176 years, the planets line up in a way that's perfect for a grand tour, a cosmic road trip, by utilizing each planet's gravity like a natural space slingshot. A journey that should take 3 decades could now zip by in just 12 years. Timing was everything. Miss this, and you'd have to wait another 176 years. Talk about pressure. So, in the summer of 1977, with a favorable cosmic window wide open, NASA sent the Voyager twins dancing into the heavens. As they zoomed from planet to planet, they were like tourists with a camera, snapping shots and sending postcards back home. What unfolded next was nothing short of astronomical wizardry. These robotic pioneers didn't just meet expectations, they blew them out of the stratosphere. They sent back the first detailed postcards of our planetary neighbors, teaching us about their rings, moons, and even the solar wind. And to think, this grand voyage across billions of miles started with a pencil, a sheet of paper, and a chance alignment of the heavens. The Voyagers, now in the space beyond our solar system, continue to redefine the boundaries of human achievement. They remind us that sometimes the stars do align for those who dare to dream big. Chapter 2. The Launch and Missions of the Voyagers. On that memorable day, September 5th, 1977, the world paused and gazed upward as Voyager 1 set off on an unprecedented space odyssey from Cape Canaveral, Florida. It was nothing short of audacious. A spacecraft flung into the heavens on the might of a Titan Centaur rocket. Like a sprinter following a starter's pistol, Voyager 2 wasn't far behind, lifting off just 15 days earlier and charting a course to trailblaze through the cosmos right alongside its twin. The aim? Simple on paper but colossal in ambition, to swing by the massive gas giants, Jupiter and Saturn, and peek at their moons, swirling mysteries in their own right. Yet the universe had bigger plans for these cosmic explorers. Before we knew it, they were sailing to the outer edges of our solar neighborhood, real-life Star Trek without the fiction, voyaging where no craft had ventured before. As the pages of the calendar turned, Voyager 1 and Voyager 2 kept on ticking, outlasting all other spacefarers in the stamina stakes. These robust travelers didn't just beat the odds. They laughed in the face of cosmic uncertainty, marching further away from our blue planet than any other human-crafted objects, boldly crossing into the vastness of interstellar space beyond the sun's embrace, over 12 billion miles from home. And just when you think they've done it all, they drop a cosmic bombshell, an enigmatic find that's left the brightest minds scratching their heads. But let's not spill the beans just yet. That's a tale for another time. Decades ago, the Voyagers gave us a front-row seat to the dramatic landscapes of Jupiter and Saturn's moons. Far from being the barren, pockmarked worlds we imagined, these moons burst with geologic fireworks and dynamic climates. In particular, Voyager 2 deserves a standing ovation. It flew past Uranus in '86 and Neptune in 1989, a true pioneer, the likes of which we'd never seen before. Even now, these twin probes aren't done making history. NASA's gotten crafty, powering down bits and pieces here and there to keep the Voyagers chugging along, planning for them to keep phoning home until 2030. Those at the helm of this mission, who've dedicated their careers to these distant wanderers, are witnessing a mix of triumph and nostalgia as their brainchildren surpass every expectation. What's next for these intrepid spacefarers? Stay tuned, because their story is far from over. Chapter 3. The Voyager twin probe's new discoveries. Imagine a spacecraft so adept at its job that it transforms the vast void of space into a gallery of cosmic wonders. That's exactly what the Voyager twins did as they danced through our solar system. Each image and byte of data sent back by Voyager 1 and Voyager 2 has been like a brushstroke on the canvas of our universe, revealing details and mysteries that, until their journey, remained hidden beyond the shroud of our night sky. They weren't just floating pieces of metal and wire. These spacecraft were precision-crafted explorers. They spun through the void at a speed slower than the minute hand of your watch, ensuring every snapshot and measurement was crisp, without a smudge, capturing snapshots of our planetary neighbors with stunning clarity. Their cameras, though not nearly as sophisticated as today's smartphone lenses, worked miracles. Long before their grand tours of the giant planets, they were already sending back postcards of the cosmos. Jupiter, the mighty gas giant, was first to pose for Voyager's lens. Its swirling storms and the great red spot appeared on our screens with such detail that it felt like a sneak peek into the universe's own art gallery. Now buckle up, because what they found on Jupiter's moon Io was about to shake up everything we thought we knew about our celestial neighborhood. Io was caught red-handed, or should we say red-hot, with volcanic fireworks. It wasn't just a static rock orbiting Jupiter. Io was alive, erupting, spewing jets of lava so high that if you stacked 30 Mount Everests on top of each other, they might just graze the bottom of these cosmic fountains. These weren't your average postcards. These were high-definition, awe-inspiring images that made our own volcanic eruptions look like mere sparklers by comparison. Just imagine an entire area the size of France draped in volcanic material. That's the kind of spectacle Voyager unveiled. As if not to be outdone, Jupiter revealed it had its own set of rings. No, they weren't as flashy as Saturn's, but they added a whole new level of wonder to the already magnificent planet. It's as if Jupiter whispered, "Look again, I've got my own secrets." And what a subtle yet stunning secret it was. Then there was Europa, Jupiter's icy companion. Voyager 2 peeled back its frosty exterior, revealing a shell that would dwarf many of the Earth's tallest mountains. It was like discovering a hidden layer in an epic space saga that suggests, hey, there might be oceans, there might be life here, hidden beneath the ice. The Voyagers were like the ultimate tourists, taking advantage of Jupiter's massive gravitational field to slingshot themselves to their next destination with even greater speed. This gravity assist was like getting a VIP pass to the best ride in the park, allowing them to visit realms beyond without it. They'd be space statues, unable to explore the far reaches of our planetary neighborhood. Voyager 1's encounter with Titan was like a spy decoding the secrets of a hazy, mysterious world. It gave us just enough to thirst for more knowledge about this moon wrapped in a dense atmosphere. Meanwhile, Voyager 2 continued on to meet Uranus and Neptune, revealing moons and winds that challenged the very way we saw our solar system. Neptune, with its ferocious winds and frigid moon Triton, flaunted its own natural wonders. We learned of ice volcanoes that erupted not with molten rock but with nitrogen and dust, defying our Earth-centric expectations of volcanic activity. Throughout these discoveries, there was Carl Sagan, the people's astronomer, who championed the idea of the pale blue dot. He insisted that Voyager take one last look homeward. Thanks to his persistence, we saw our planet as a mere speck in the vast cosmic sea, a humbling image that put our place in the universe into perspective. And in a gesture that could melt the coldest space rock, Voyager 1 turned around on Valentine's Day and took a family portrait of our solar system, a token of love from the final frontier to us all, here on Earth. Imagine drifting through the star-studded tapestry of space, where the Earth becomes a mere pixel in a vast cosmic portrait. There, in the ocean of the universe, an image stands as a testament to human curiosity, the pale blue dot, Earth captured from an awe-inspiring 3.8 billion miles away. In this snapshot, Earth shrinks to a speck, a minuscule orb floating in an immense cosmic sea, nudging us to reflect on our tiny spot in the grand celestial dance. Now consider the Voyager spacecraft, our enduring space explorers. Picture these machines, not just as marvels of technology, but as storytellers recounting their odysseys across the solar system. Decades into their journey, they continue to whisper secrets back to us from the void, their messages traversing the cold expanse to reach us. In this ongoing saga of exploration, Voyager 1, now over 14.5 billion miles from home, astounds us yet again with a baffling new chapter, discovering 500 previously unseen objects. These mysteries of the cosmos challenge our understanding, sparking curiosity about what else lies beyond our solar grasp. But how do these spacecraft manage such feats? It's like they have a secret superpower: resilience. Picture Voyager 1 as a seasoned spacefarer, launched in 1977 with a body made to last, a heart of redundant computer systems that serve as its pulse. If one system falters, another takes over, ensuring the mission goes on. Behind this enduring success is a careful balancing act of power management. The Voyagers are powered by radioisotope thermoelectric generators, which transform the natural decay of plutonium into electricity, a steady, reliable heartbeat that has sustained these probes for over 4 decades. And it's not just about having power, but using it wisely. The space engineers have a meticulous strategy, akin to budgeting for a long road trip. They know when to conserve energy, turning off gadgets that aren't essential, just like you might switch off the AC to save fuel. In the frigid vastness of space, such decisions are crucial. The probes have had to bundle up, adapting ingeniously to the biting cosmic winter to keep their scientific instruments warm and functioning. Voyager 1, our postcard from the edge of the solar system, whispering secrets of the cosmos back to us across an interstellar divide. As it soars through the heavens, the distances involved are so vast that even light, that rapid courier, takes nearly a day to traverse the gap between us and the spacecraft. On Earth, we rely on the impressive deep space network to catch these whispers from the void. Picture an intercontinental game of catch, with NASA's trio of ear-like dishes in California, Spain, and Australia, each taking turns to listen intently to our distant explorers. These dishes capture the faint signals, a testimony to human ingenuity and curiosity. Imagine you're standing on a beach, gazing out at the vast ocean. The solar wind is much like the sea breeze you feel on your face, and the heliosphere, a bubble inflated by this solar breath, acts like a colossal protective shield around our solar neighborhood. As Voyager presses on, it's like a ship steadfastly cutting through the waves, reaching the point where the sea breeze meets the resistance of the calm air beyond. The heliopause, the boundary of our sun's influence. Now, Voyager 1's mission has thrown us curveballs. The heliopause turned out to be not just a clear cutoff, but a complex, fluctuating frontier shrouded in mystery. Our humble spacecraft found that the solar wind's push was not where it was expected to be. And even as it crossed this cosmic boundary, the magnetic fields didn't change as predicted, leaving scientists scratching their heads. Think of these fields as invisible threads weaving through space, and Voyager 1 expected to find a shift, a cosmic tapestry changing patterns from the sun's threads to the interstellar weave. But the pattern remained eerily the same. This discovery is much like opening a book expecting one story, only to find the narrative is far more intriguing. Adding to the intrigue, Voyager 2, the twin probe, confirmed these findings, emphasizing the symphony of our cosmos plays on a scale that challenges our best models. The data we've gleaned has made us rethink the very nature of our sun's surroundings, suggesting that the aftermath of stellar fireworks, supernovas, may have shaped our cosmic shore. The voyages of these probes are not just scientific quests, they are epics of human persistence and curiosity. These twin crafts are now heading towards the constellations Ophiuchus and Cetus, carrying golden records, a cosmic time capsule with the sounds and images of Earth. They're our ambassadors, potentially outlasting humanity, each equipped with a message of our hopes and dreams. As their power diminishes, we face the poignant reality of saying farewell to our distant envoys. Their journey reminds us of the power of questions and the thrill of the unknown. These spacecraft, against all odds, continue their silent trek through the cosmos, challenging us to rethink what lies beyond our solar sanctuary and what tales are yet to unfold in the interstellar expanse.